So if we need to test to see if there's a statistically significant difference between two proportions, then we use the z-score, and then the formula is the sample proportion from one group subtracted by the sample proportion from another group, divided by the square root of the sum of those standard errors. So that's going to be p hat 1, or if you have p1, you'd want to put that there. 1 minus p hat 1 over n sub 1, so the sample size for the first group, plus p hat 2 times 1 minus p hat 2 over n sub 2. Okay, so the proportion that we're talking about is being admitted to the hospital. So p hat 1 should be the proportion of people admitted to the hospital. So there's 9 out of 20 people admitted to the hospital. So p hat is 0.45 for this group. And then down here, 7 divided by 20, so p hat is 0.35. So we've got 0.45 minus 0.35 in the numerator. We're going to divide that by the square root of 0.45 times 1 minus 0.45 all over the sample size for the first group. They both happen to be equal. They're both 20. And then same type of thing over here, just 0.35 instead. Sorry for my penmanship with my mouse here. Okay, so 0.45 minus 0.35 is 0.1. And then down here, I'm going to do each fraction separately. First fraction's numerator is 0.45 times 0.55 divided by 20. So we have the square root. Take this and add it. 0.35 times 0.65 divided by 20. Oops. Okay, and then we can add those two numbers. And then that's going to be the square root, so I'll do that while I'm here. Take the square root of the denominator. That's probably enough decimals. So we've done the square root, so I've dropped that. So the last part is to do 0.1 divided by that denominator. So I got a z-score of 0.65 roughly. If you're familiar with z-scores, you're probably going to be able to guess what's going to happen next. But to make our decision and to calculate a p-value, we need to know the null and alternative hypothesis. So if you're conducting a test to see if emission in hospital 1 is greater than emission in hospital 2, then you're doing a right-tailed test because numbers to the right are bigger. So this is the greater than sign. And if it's less, then you're doing a left-tailed test. And then finally, if it doesn't specify a direction, if it says just a test to see if there's a statistically significant difference, then you got a two-tailed test. So what you want to do, regardless of whether it's one-tailed or two-tailed, is you want to look up a z-score of 0.65. So I'll go to Google and I'll do z-score to percentile calculator. I typed in, I'll move it up here so you can see what I typed. I typed z-score to percentile calculator. Let's try the first one. Okay, this is good. We can plug in 0.65 and then it's even got a two-tailed option here for us. But if you're just, oh, there we go. If you're using the old-fashioned table in the back of the book method, I just want to show you how it works. Z-score tables and their calculators often just tell you the area to the left. So if you look up the z-score of 0.65 in a table, it'd give you for percentile 0.74. You just have to do 1 minus 0.74 to get the right-tailed test. But this calculator happens to give it to us. So if it was a one-tailed test, this is my p-value because that's the area in the tail for the alternative hypothesis, roughly 0.26. If it's a two-tailed test, you just got to double that. So this is be 0.54 over here. Sorry, 0.54 total because this is also 0.26. I shouldn't point to that, right? 0.54. These two added together is 0.54 is what I meant. So two-tailed, you would just double the area in the tail, or you could just click two-sided. I think they'll do the same thing. Well, maybe I did my math wrong because it's 0.515. Oh, because I rounded. That's right. Okay. So that's your p-value. The area in that tail is the p-value. And the p-value tells you the probability that this all happened by random chance, basically. This p-value is pretty large. Whether it's a one-tailed or a two-tailed, 26% chance, 54% chance that it was just by accident. That means there's not enough evidence to reject the null hypothesis. So even though our sample proportions are different, that could be just due to random chance. It's not a big enough difference in order for us to say that hospital 1 has something going on that makes them admit people more often than hospital number 2.